Welcome students, this is Professor Pushkar Shinde. Today we are going to discuss some concepts of Unit 6 associated with bus cycle. So we are going to discuss 80386DX signals. We are going to look at the signal diagram, description of signals. Then in brief we are going to discuss 80386DX bus cycles, system clock, bus state, and the pipeline and non-pipeline bus cycle concept. So this is the part 1 of the video session. So as you know, 80386DX is having various signals that we had discussed in the previous session. We're going to further look at those signals in detail. So these are the various pins of 80386DX. It is having a 132 pin grid array package. So there are 132 pins in 80386. Out of that, 32 pins are for address bus, 32 pins are for data bus. Then you have ready bar, NA bar, BS16 bar, various pins on which the different signals are given in 80386DX that we are going to discuss in this session. So speaking about the description of signals, when a signal is having hash bar, the named signal is active low. That means when the signal is having zero value, it is active. This is the meaning of hash when a signal is having a hash given with it. I is an input signal, O is an output signal, I slash O is input and output signal. This is how the representation is done of signals. Dash indicates no electrical connection for that pin. So these are the various functional signal groups for the various pins of the 80386 on which the signals are given. These are the groups of them. So you have the address bus, which is a 32-bit address bus. Then you have byte enabled signals. So the byte enabled signals B0 bar, since hash is given, that means when it is having zero value it is active. B0 bar, B1 bar, B2 bar and B3 bar. These are byte enabled signals. Then you have W slash R bar, that is write slash read signal. When W is having value 1, this signal is having, that means when W slash R bar is having 1 value, it is a write signal. When W slash R bar is having a 0 value, it represents a read signal. Similarly, you have D slash C bar. When it is having 1 value, it's a data signal. When it is having 0 value, it is a code signal. M slash IO bar, when it is having 1 value, it is a memory related signal. When it is having 0 value, it is a input output related signal. Then you have log bar. Similarly, you have ADS. So these all are bus cycle definition signals. Then you have bus control signals. Before that, you have the data bus, 32-bit data bus D0 to D31. ADS bar indicates that valid address has been put on the address bus. NA bar is the next address signal. It is used to indicate a pipeline bus cycle. When NA bar is active, that means it is having zero value, it indicates that the next bus cycle has started. So it is used in pipelining it is used in. So it is used in a pipeline timing diagram. BS16 bar, it indicates that whether it's a 32-bit data transfer or 16-bit data transfer. So when BS16 bar is 0, it is a 16-bit data transfer. When BS16 bar is 1, it is a 32-bit data transfer. Then you have the ready bar. It is used to indicate that the actual data transfer is being done between the data bus and the memory. So whether it's read or write, that actual data transfer starts only when ready bar is active, that is having zero value. These are all bus control signals. Then you have bus arbitration signals, hold and hold acknowledge. HLDA is for hold acknowledge. You have coprocessor signaling related to the coprocessor 80387. Then you have interrupts related signal INTR, NMI and reset. NMI is non-maskable interrupt. So these three signals are associated with interrupts. So you have three pins associated with these three signals. So these are the different signals given on different pins of the 80386DX. These signals, some of them are used in the timing diagram to represent the machine cycle. So this is the pin description table that we had discussed in the previous session. So we are just going to briefly look at it. So you have the data bus D0 to D31, address bus, 32-bit address bus. It provides output to the physical memory or input output addresses. It loads the address on this address bus. Data bus is load the data value. So what happens is that when it's a read cycle, from memory the data will be taken into the data bus, and when it's an output cycle, from data bus the value will go into the memory. So depending on whether it's a read machine cycle or write machine cycle, during read machine cycle from memory value will be read into the data bus, and during write machine cycle from data bus the value will be copied into the memory. Then you have the byte enable. Byte enable indicates which data bytes of the data bus take part in the bus cycle. So which bytes of the data bus are taking part in the bus cycle. That means the data bus is 32-bit, so it is divided into 4 parts, each of 8 bit each. So which 8 bits are taking part in the data cycle can be machine cycle can be decided by this B0 bar to B3 bar. Then you have W slash R bar. Write slash read is a bus cycle definition pin that distinguishes write cycles from read cycles. It means when it is 1 it is a write cycle, when it is 0 it's a read cycle. Similarly D slash C bar is data slash control. Data or control signal is being activated. M slash IO bar is memory slash input output. Then you have lock bar, ADS bar, NA bar, ready bar and BS16 bar. So these are the different signals given on these pins which are used in the machine cycle. So this is the system clock, how it is represented. So you have is that you have high and low values of the clock. You have a system clock and you have a processor clock. So system clock is basically twice cycles of the processor clock. That means for one processor clock you have two system clocks. So within one processor clock period there are can be two system clocks. So the processor clock and system clocks will also be a part of the machine cycle representation diagram, where you will be showing the clock cycle and the processor cycle. Remember, system clock has having twice the cycles as the processor clock. So if there is one processor cycle, you will have two system clock cycles in that period. So speaking of the system clock, the clock 2 provides the fundamental timing for the Intel 386DX, divided by 2 internally to generate the internal processor clock used for instruction execution. That means processor clock is half of the system clock. The cycles of processor clock are half of the system clock. Internal clock is comprised of two phases, phase 1 and phase 2. So one machine cycle has two bus states, bus state 1 and bus state 2. One bus state has two system clock cycles and one bus state has one processor clock cycle rather. So these are the bus cycle definition signals. What is the bus cycle type upon different values of the bus cycle signals? So you have M slash IO bar, D slash C bar, W slash R bar, and the bus cycle type. So when M slash IO bar is low, that means you indicate it's a input output. D slash C bar is low, that is it's related to control or code. W slash R bar is low, that is it's a read. In that case, it's a interrupt acknowledge cycle. When M slash IO bar is low, D slash C bar is low, and W slash R bar is high, it cannot occur. When M slash IO bar is low, that means it's a input output. D slash C bar is high, that is it's a data related, and W slash R bar is low, that means it's a read. So that indicates it's a IO data read. Similarly, you have IO data write, memory code read, then M slash IO bar high, D slash C bar low, and W slash R bar high indicates a halt or shutdown depending on the values of B0 bar to B3 bar. M slash IO bar is high, D slash C bar is high, and W slash R bar is low. That means it's a memory data read. That is, it's a memory data read or memory data write for the other values of the same signals. So speaking of the bus control signals, we have ADS bar that gives the address status. When ADS bar is having 0 value, that is active, it indicates that valid address has been loaded into the address bus. Ready bar is a transfer acknowledge signal. When ready bar is active, that means 0 low value is there in it. At that time only the data transfer can start. So when ready bar is active, if it's a read machine cycle, the there will be read from the memory into the data bus. When ready bar is active and it's a write machine cycle, then from the data bus values will be copied into the memory. Then you have NA bar, next address request. NA bar is used in the pipeline timing diagram. So in pipelining, you have NA bar being used in the pipeline timing diagram. You have BS16 bar. It indicates that when BS16 bar is active, that is 0 value, it indicates a 16-bit data transfer, and when it is high, it indicates a 32-bit data transfer. When you have bus arbitration signals, hold is a bus hold request, HLD is a bus hold acknowledge.